Alright, it's section 7, y'all. Scatter plots and trend lines, or what's called best fit lines. Alright? To write the equation of a trend line as well as a line of best fit, and to use those lines to make predictions. Okay? You can determine if two sets of numerical data are related by graphing them. In this process, you may find that you can use a line to estimate or predict more values. A scatter plot is not a straight line. The data is going to be grouped together in some way. There are three different ways. There is a positive trend that you see here. Okay, it's almost as if the data is rising, and one of the things that I'm going to ask you to do is kind of look at the questions in your book and look at trend lines or best fit lines. But I'll give you kind of an idea. If I use these 2 points right there, I can create a line that goes through them that is a fairly good representation of all the data. It's not perfect. It would be possible to also use that line right there to do that. And generally the concept is that you pick 2 points that if you were to take the data, you're kind of cutting it in half. Half of it shows up above the line and half of it shows up below. It wasn't quite perfect, but that's okay. This one has a negative correlation. As the value of x increases, the value of y decreases. So to pick a couple points here, I could pick this one right there, and let's say this one right here. And then I would draw my line straight through those two. And that one is a pretty good prediction because you've got 4 below and 4 above. All right. And then there's this stuff. It's no correlation whatsoever. As x increases, you have no idea what y is going to do. For positive, as x increases, y increases. So there are 3 different types of correlations or relationships between the data. So the next slide is some vocab. Trend line, a line on a scatter plot drawn near the points that shows a correlation. Interpolation is estimating a value between 2 known values. Extrapolation is predicting a value outside the range of known values. The line of best fit is the trend line that shows the relationship between 2 sets of data most accurately. 5, causation. A change in one quantity causes a change in a second quantity. A correlation between 2 quantities does not always mean that there's correlation. Okay? So just because one value goes up and the other value goes up, it doesn't mean that one of them caused the other one to happen. Okay? But if one value increases and the other value increases as a result of that, then that's called causation. This is a language arts term as well as a math term and a science term. Okay? So if I put a Mento into a Diet Coke, it's going to cause the Diet Coke to fizz or explode or whatever it is that happens. That is causation. If the Diet Coke were just sitting there and I never put a Mento into it, it would never fizz over. Okay? Honestly, the best way for you to do this is to look at the stuff in the book. And the only reason why I say that is because it can be a time-consuming process. So what I would like for you to do, if possible, is right now pause this video and look in the textbook. Okay, if that means you pull up the online one, whatever. But spend a little bit of time looking at 1, 2, and 3, because I do have a couple practice questions here. Actually 1, and then the check yourself sort of stuff. So hopefully you pause it. Okay, so identify whether a relationships are causal. In the following situations, is there likely to be a correlation? If so, does the correlation reflect a causal relationship? Okay, so the cost of a family's vacation and the size of their house. Is there a relationship? If a family spends more on vacation, does that mean that they live in a bigger house? I would say no. just because maybe they bought a smaller house so that they can spend more money on their vacation. We want to think about these, and really here's the biggest point, the biggest part. If you believe there's a relationship between the family vacation, the cost of a family vacation, and the size of their house, then explain it. Give me a reason, and don't just say because. You have to have a purpose or a reason behind it. So I would answer no relationship with the first one. And I'm not looking at the book, okay? I'm answering this based on my own experience, based on my own thinking. Just because a family spends a lot on vacation doesn't mean that their house is any bigger. Now, you might think that if they spend more money on their vacation, they probably live in a bigger house because they have more money. Okay, like I said, explain it. Now, would it be causal if you felt like there was a relationship? Probably not. Them spending more money on vacation, would that cause them to live in a bigger house? No, it would actually do the opposite. Okay, time spent exercising and the number of calories burned. Is there a correlation? I would say yes. The more you exercise, generally, the more calories that are burned. And I would call this causal. Okay? More exercise equals more calories burned. Look at that. Even in an answer, I'm using an equation. All right, it's okay. Okay, so I would say yes, it's causal, and that the more you do exercise, and generally it's true. I mean, unless you're eating like a donut while you exercise. That's kind of a funny picture. Okay, so that's one of the parts. All right, and then we've got the check. Make your scatter plot of the data. What type of relationship does the scatter plot show? Draw a trend line and write its equation. Predict the average maximum daily temperature at the latitude of 50 degrees north. So you'll notice that we don't have 50, so that would be the process of extrapolation. Okay? Just went over the 7:30 minute mark, 7 minutes and 30 second mark. So I'm going to say goodbye. See you.